Hello, everyone. What I want to do is go over summer 2024 collected homework 2. Just like before, I think if I remember correctly, the grades were pretty good. Definitely some people didn't do so well, so worthwhile to go over everything. Okay, so problem 1, Jennifer's loan 500 at the beginning of years 1, 2, and 3. So immediately let me draw a time diagram. Remember, year 1 is 0 to 1, year 2 is 1 to 2, year 3 is 2 to 3. So the beginning of year 1 is t equals 0, beginning of year 2, t equals 1, beginning of year 3, t equals 2. Okay. So I'll just draw all these because why not? It only goes up to 10. I'll have to draw 2 more, whatever. All right, so this is the cash in. And it's X at the beginning of year 7, so that is t equals 6, and then the rest 7, 8, and 9, or 525. All right. You don't really need 10, but whatever you draw, it really doesn't matter. Seconds. There it is. So yeah, you can you can really as I mentioned in video and examples, so sorry, this is the cash out, this is what you're paying. You can really time value everything at any time whatsoever. I think it's just easiest to time value it when where you have the unknown. If you have multiple unknowns, just do it at either one. Alternatively, you could take the present value of everything. That's kind of what most people do. No harm there. I'll do it both ways. Yeah, I always forget how annoying it is to switch colors here. Whatever. All right, so let me, I think it's just good exercise to time value things at a specific date. Again, if you want to take the present value of everything, that is what most business and finance people do. Not sure why, but they do that. So yeah, this first 500, the value is gonna grow by 1, 2, 3, 4, 5, 6 years if I time value everything at t equals 6. 500, 1.07. Interest is at 7%. This 500 grows by 1, 2, 3, 4, 5 years. Et cetera, et cetera. Well, we only have, so sorry, this is going to get a little crowded. So for the cash in, this is the only other one. This is going to be equal to X. Then we have to discount, kind of go backwards in time. This 525 by 1 year, this 525 by 2 years, the last 525 by 3 years. So divide by 1.07 or 1.07 to the -1. Doesn't matter. Probably the former is easier to fit, but all right, and so you get 2,107 and 4 cents equals X plus 1377.77. So you get X is 729 27, right? Now, if you want to take present value of everything, that's fine. I actually didn't compute both sides doing that, so I'll skip this step, but I'll otherwise just take present value of everything. Shouldn't take too long to write. So the first 500 is already at t equals 0, so you don't discount that by anything at all. This one gets discounted by 1 year. So I don't have to do anything. This is discounted by 2 years. Sorry, it's discounted by 1 year, so need exponent of -1. This x is going to be discounted by how many years? Let's see. Let me move this over a bit. It's looking a little funky here, kind of all the way over to the left. Right. So yeah, again, now I'm sorry. I am I'm not going to use red, but time valuing everything t equals 0. I'm taking the present value of everything. All right, so this 6 here gets discounted by 1, 2, 3, 4, 5, 6 years. 525 is 7 years. This is 8 years. And this is 9 years. So it's the same thing as what I had before. You're just essentially mathematically multiplying everything by 1.07 to the -6th. You're multiplying both sides by 1.07 to the -6th. Either way, still get 729.27. All right, 2. Let's say X is the price of the machine. So just like in the example, we're going to time value all the costs and set them to be equal, so that if you pay any more than what we get doing that to the machine, then you're losing money time value. Okay. Yeah, so the kind of point here is whenever you make a business decision, you really have to time value everything. Because, well, if you can invest your money at a certain interest rate, then any money lost is money you could have invested. It really only makes sense to time value everything at a certain interest rate. Okay. So let's do employee costs. You have 6,000 per employee, 10 employees. For 4 years, and 6,000 at the end of each month. So 6,000, that could be, so that'd be like 72,000 a year. And that could be, even if it's like a company like Amazon, yeah, that makes sense. If you're doing like line work at Amazon, working, dealing with packages, because that includes benefits, healthcare, pension, etc. So if I had to guess, even, working, 15, 20 bucks an hour at Amazon or something, probably when you add up all the health benefits and pension, it probably comes to about 70 something thousand a year. That's my guess. Just a guess. All right, so this is employee costs. I mean, I guess you really don't need this, but so yeah, it's you got 6,000 per employee, 10 employees, so 6,000 times 10 is 60,000. So that's how much you're paying at the end of each month. all the way until the last two, 47, 48, 60,000. 60,000. All right, you could take the present value of everything or take the accumulated value of everything or really just date I mean, yeah, you can really date everything, basically however, where you can date everything to wherever you want. Probably only makes sense to do present value or accumulated value, because if you can avoid going forwards and backwards, might be a little easier. I guess you could say the same thing for this problem here, but so yeah, in this problem here, you could take the accumulated value of everything or just the present value of everything. I guess just it's a little easier, the computation with X here to date everything when X occurs. Not much easier. All right, so take the accumulated value. This 60,000 accrued. Let's start with this 60,000 here. Then the next one here, 47, accrues 1 period of interest. So it's 1.005, because it's 0.5% per month. I guess I'll redo it doing present value. So the last one accrues 47 months of interest. So 1 to 2 is 1 month, 1 to 3 is 2 months, or 2 to 3 is 2 months, 3 to 4 is 3 months. So 1 to 48 becomes 47 months. Or rather, 1 to 2 is 1 month, 2 to 1 month, 2 to 3 is another month, 3 to 4 is another month, 47, 48 is another month. The 1 to 2 is total of 2 months, 1 to 3 is a total of 3 months. Sorry, 1 to 2 is a total of 1 month, 1 to 3 is a total of 2 months, 1 to 4 is a total of 3 months, 1 to 48 is a total of 47 months. Sorry about that. Okay, yeah, it's geometric series formula, 1 minus 1.000. Sorry. Too many O's, too many zeros. 1.005. 1 minus 1.005 to the 48th over 1 minus 1.005. 325, 3245, 869. 933. Machine costs are much simpler. So there's no upkeep. I mean, probably a little unrealistic. Obviously got to maintain your machines and fix them and stuff. Whatever. Don't really need 1 and 2 here, but whatever. So you get, so remember, just like in the example, costs are positive because we have a lot of them. Money you get back is negative. Just make life simpler and have as few minus signs as possible. So this is just going to be accumulated value. Let me move this up a bit. I have a lot more room. I'm definitely running out of room here. So this accrues 48 months of interest. This accrues nothing. So it's 1.27049x minus 125,000. So you set this to be equal to this. So what I circled are going to be equal. And just solve for x. X is 2653. 206. 37. All right. Yeah, I guess if you want to take present value of everything, let me just show you how it would go. I didn't compute the numbers. That's fine. You can go into the calculator and do all that. You want to check your answer. Actually, I don't want to do that. All right, so I'll start with this. So x is at t equals 0, so we don't do anything to that. Discount the 125 by 48 months. Let's get rid of all this. Really wish they would make the eraser much simpler, easier to use. Okay. So it's going to be x minus 125. And I think most people did it like this. All right, so this is the present value of machines. Just discount the 125,000 by discount that by 48 months. Okay, here it's going to be a lot different, of course. So keep my sanity here. Let's do it like this. Let's work backwards. So let's discount this first one. Going to be by 1, so 1.005. Again, I'm taking present value of everything. This 60,000 discounted by 2 months. This is by 3 months. And finally, the last one is by 48 months. All right, so what you would do is factor out. There's a formula, I guess, for this alone. I mean, I personally usually don't remember that formula. So I would just use the regular geometric series formula after I factor out 60,000, 1.005 to the minus 1. Do that in a second. All right. One plus, sorry. This 1 over 1.005 to the 1 power. The squared. So this all the way up to 47. So this would equal 60,000. Or if you want 1 over 1.005, that probably is a little simpler. Makes a little bit more sense, probably. So it's 1 minus 1 over 1.0005 47 over 1 minus 1 over 1.005. So all you would do next is what I'm going to circle, set all these to be equal. So whatever this is, set this to be equal to this, and you get the same answer right here. Okay, number 3. Most people did this right, but yeah, so some people didn't. Quite a few people didn't. So let's go through it. So Bank A, we have nominal interest compounded every 4 months. So that's 3 times a year. There's 3 4-month periods in a year. 4 plus 4 plus 4 is 12 months. Not very subtle. So it's 3 times a year. This is 0.05. And I mean, you really can. I mean, you can. I think the easiest thing to do for these problems is just get the actual yearly equivalent effective annual interest rate for each Bank A and Bank B. Or rather, get it for Bank A, and then Bank B has to offer that same interest rate or better to be competitive, and then convert that to a nominal weekly interest rate. All right, so per year, this account is going to earn an interest rate of 5.084%, close to 5%, but not exactly. So remember, all these nominal interests, continuously, weekly, daily, whatever, discount, same thing. They're all going to be similar to each other, not too far off from each other. Okay, so Bank B. So again, this bank has to grow by 5.84% each year, or this account rather, in Bank B, in order to be competitive with Bank A. So the question is, what is the nominal weekly interest rate that corresponds to? Just plop into the formula, plug and chug, 52. 1 plus my interest rate, my annual interest rate. 1 over 52 minus 1. Again, close to 5%, 0.04961. And that's that. Okay. These are annoying, but you know, it is what it is. So let's do A. This is really plug and chug. I'll try to do this quickly. I is 3%, 0.03, so plug into the formula for I2. It's always M1 plus your interest rate to the 1 over M. Again, all these are going to be close to close to 3%. So here we're doing semi-annually, monthly, weekly, daily, and continuously. Do the same thing, but instead of 2, it's 12. 029595. So for weekly, excuse me, 52. .029567. Yeah, the challenge here is fitting the damn thing into the screen. I'll have to erase maybe. And for the other one, we just use the other formula. For given I, what is IM? All right, and last but not least, yeah, I should have enough room. Remember, this formula is ln of 1 plus I. A few people said it's 0 because you're raising something to infinity. Or it's 1.03 to the 1 over infinity. So that's 0, 0 minus, sorry, it's 1, 1 minus 1 is 0. That's not correct. It's a limit. It's like a Calc 2 limit. You don't need to know the L'Hopital's rule trick to do the limit. You just need to know the damn formula that the limit becomes ln of 1.03. So, right, again, close to 3%. Okay, B. So I2 is 5%. I is always 1 plus IM over M. So I2 is, all these are 5%. M is 2. Fix that. 0.05065. I'll just do M equals 12. So again, I just want to emphasize always for this problem, or for B, IM is 5%. We're just plopping into our formula. So I12 is 5%, so it's I12 over 12 to the 12th. 0.51162, etc., etc. So here is e to the I infinity, which you also call delta. So this is 0.05127. Okay, last but not least, Jen makes initial positive 2x into an account, pays interest nominal rate of I. I do this because Exam FM does this annoying thing every now and then. Even though I like to use I would prefer to reserve I for an effective annual interest rate. Exam FM is not that nice. So they love to confuse you and trick you. Yeah, again, as I always like to say, I don't write the damn exam, so if you don't like it, go complain to the Society of Actuaries. Don't complain to me. I've never had anyone complain to me about the exam. That make no sense at all. I'm not an actuary, but whatever. All right, so let's say A is for Jen. So A of T, we're doing Jen first. All right. So it's 2x is the initial deposit. So just like before, I'll do it like this. If this is kind of like my Every 6 months is twice a year, so this is my I2. So I2 is basically my I. So so my effective annual interest rate is going to be 1 plus I2 over 2 squared minus 1. And then we're going to do plus 1. Equivalent effective annual interest rate right here. I'll just do it once, just like I did in the video. But I2 we're saying is I. Oops. So yeah, there's too many brackets here. So I'll do another parentheses, I suppose. So it's this to the t. Well, the ones cancel. So I should be able to squeeze it in here. 2x 1 plus I over 2 to the 2t. All right. So the interest earned in the last 6 months of the 5th year. Remember, the 5th year is 4 to 5. First year is 0 to 1. Second year is 1 to 2. So the last 6 months is 4.5 to 5. So we're figuring out how much you've made in that 6 months. So it's how much more you have after 5 years versus 4.5 years. That's how much you've made in the last 6 months of the 5th year, the year 4 to 5. So it's a of 5 minus a of 4.5 to x, plop in 5. And always with these problems, it's designed so that the algebra is easy. Plop in 4.5, that'd be 9. So in particular, you can factor this whole thing out. So it's 1 I over 2 minus 1. That's a weird ass looking bracket. So it's 2x 1 plus I over 2 to the 9th. Minuses cancel times I over 2. So, if you want to move things around, by all means, but you have to do that. So I'll use blue, I guess. So this here is the interest earned in the last 6 months of the 5th year. Okay. So yeah, this is Jen. Now let's do who's it, Chris? Okay, let's say B is the accumulation function for Chris. So if I wasn't clear, A is the accumulation function for Jen. So he initially invests 3x. And it's a simple interest rate of I. This is 1 plus IT. So same thing, B of 5 minus B, 4.5. 3x 1 plus 5i. One plus 4.5i. So that's going to be equal to, well, 3x's cancel, 15 minus 13.5. Right. Yeah, it'd be 15 minus 13.5 is 1.5. So 3x I over 2. So these are gonna be equal in blue. This one and this one. So just set these two here in blue and here in blue equal, because the interest earned, you're given that the interest earned in the last 6 months of the 50 year is equal. So to X. So just like the video, nothing too. I mean, certainly if I was just like, oh, just do this problem, without any hints or anything, it's a bit tricky, but with seeing how it's done in the video, it shouldn't be too bad. Okay, so what cancels? The X cancels, the I's cancel. You can even cancel the 2's here. So you're left with 2, 3/2. I'll keep it as red, because why not? Yeah, just divide by 2. This is 1 plus I over 2 to the 9th. So simply solve for I. 0.09216, a bit high, almost 10%, but that's fine. Okay, yeah. Any questions, let me know. Hopefully this helps. Homework is due tonight, and exam is coming. I never ever get used to how fast these summers go. And we're already in our first exam, and we're already a third of the way through. At the end of next week, we'll be halfway through. But all right, so long, take care. Bye-bye.